own adventure, the struggle for security. Meet Hero. Hero is application source code on a developer's laptop. Hero longs to be a real application running in production, serving end users, and we're going to help Hero live their dream. We're going to help Hero navigate hundreds of CNCF projects, choose which ones to use, integrate them with one another so Hero can run in production. I'm Whitney. This is Viktor. Together, we host a show called You Choose that's on Viktor's DevOps Toolkit YouTube channel. And in our show, each episode is a different system design choice. So for each episode, we gather all the relevant CNCF technology that can do that thing, whatever it is. We invite someone to speak from each project onto the show, and whoever's representing the project gets only 5 minutes to tell us about their technology, because we don't want them to drone on too much about the nitty-gritty. We just want an overview of what it does. If they go over 5 minutes, Viktor loves to, we have a gong that Viktor loves to use. And so, after that, we ask the community to vote on which technology they want to see in our ongoing demo. So the idea, when you vote today, the idea is not to vote on the best technology, but to vote on the one you're curious about and the one you want to see demoed for you. So based on the choices made in our show, right now we have a demo environment running on Viktor's laptop's connected to it. It's an AWS EKS cluster that we're defining declaratively with cross-plane resources. We have Argo CD running, and our application is already deployed. There's an ingress, a contour, and so therefore we have end users already talking to our application based on choices we've already made. So it sounds like Hero already is running in production. What's the problem? What are we doing here today? Well, our production cluster has no security. Bum, bum, bum. Okay. So right now we're endangering the application, the system, and the users. So we need to fix this, and this is where you come in. We need your help. So please scan this QR code. You're going to get a screen that says something boring, but when it's time to vote, you'll be able to vote by scanning this. We're going to go through 3 system design choices related to security today. We're going to add cluster level policy. We're going to add runtime policy, and then we're also going to secure pod-to-pod communication. So here we go. Let's do the thing. If you don't get this now, it'll come up later when the quiz comes up. All right, we're going to help Hero live their dream and be in a more secure production. So first up, let's talk about admission controller policies. We have 3 choices here: Kyverno, OPA Gatekeeper, and KubeWarden. But why do we need cluster level policy at all? Well, first off, as things stand, our applications can become bloated and use way too many resources, or they might run outdated versions of software, or they might run untrusted container images, maybe from suspect registries. So we need to add policy to fix this. What is policy? Policy makes rules about actions that are or are not allowed to happen to objects in our system. And these are organization-specific rules. So, for example, you can make rules that would limit resource consumption, or rules that would, looks like I already clicked it, that would make sure you run certain versions of things, or rules that make sure that container images are verified. And like a bajillion other things. This is the tip of the iceberg. So how does it work? When you write a cluster level policy, you add configuration to the Kube API that says that if any request comes in that falls under the jurisdiction of this rule, what I want to do, and that's called an admission controller webhook, that configuration. What it's going to do is it's going to send the request to admission controller software. So the admission controller is a piece of software that's running, and it can be either a validating admission controller or a mutating admission controller. So a validating admission controller is just going to return yes or no. Yes, this is allowed to be created, or no, it's not. Mutating might change something about the object and then send that changed object back to Kube API. But either way, it's going to send a response, and then Kube API is going to act in accordance with organization policy. So let's talk about our 3 tools and what differentiates them from one another. Kyverno is an admission controller that is built to be used in Kubernetes. So when you use Kyverno, you write your admission controller policy in YAML. Kind of, yeah. It's actually Kyverno JSON query language. That was the first time you spoke this whole presentation.
I said too much already.
So Kyverno JSON query language, which is a YAML, it's meant to look and feel like YAML with the idea that if you're someone writing policy for Kubernetes, you're probably very familiar with working with YAML. Then there's a lot of other bells and whistles, but I'm not going to talk about those now because they're not differentiating. So now we have OPA Gatekeeper. The OPA part stands for Open Policy Agent, and OPA is a policy engine that can be used across your entire estate, not just for Kubernetes. Then the Gatekeeper part is a wrapper for OPA that pulls it into Kubernetes, so you can use OPA with your Kubernetes policies, with your Kubernetes resources. So OPA Gatekeeper, you need to write your policy in a language called Rego that's notoriously difficult to use. So it makes a lot of sense if you're already using OPA elsewhere in your system, maybe not so much sense. I don't know, maybe you like to torture yourself and you want to use Rego. It's up to you. I'm not here to judge. And then the third one is Kubewarden. With Kubewarden, Kubewarden folks, they're like, you know what? I don't want to write policy in YAML, and I don't want to write policy in Rego. What do I do?
You can use Rego with Kubewarden.
You can. If you really want to punish yourself. So with Kubewarden, you can write your policy in any language you want, and then you compile it into a WASM module, and that WASM module runs as part of the Kubewarden policy engine. This one is a less mature project than the other two, but it still does have some of the same bells and whistles. Like you can verify container images, for example, or use OpenTelemetry or SigStore. So it's time to do the first set of voting. Which one of these do you want us to implement? Do you want Viktor to implement in the demo today? Yay. I'm relieved every time that it works. Kyverno's in the... Remember, this is not a popularity contest. This is just what you're curious about.
That's what she says.
All right,
okay.
We're settling
Shall we go with Kyverno?
Yeah, Kyverno it is.
Okay. So what I'm going to do is that first I'm going to copy some policy, this one, into infra directory. And I'm going to do that first without showing you what it is, mostly so that Argo CD picks it up, deploys it while I'm explaining what's happening. Doesn't matter. Nobody writes good comments anyway. So what did I just push to Git, right? This is the file. Basically, this is a simple policy, a couple of very simple policies. This one says that, okay, if you see a deployment and in a namespace production, and somebody tries to create or update a deployment in that namespace, then the spec field, replicas field inside of spec must be greater than 2, meaning you need to have more than 2 field replicas in spec, needs to have a value of 3 or more, right? And that's, that was the cluster policy, and then we have another policy that says, hey, if somebody creates something called SQL claim, whatever that is, and somebody tries to create or update, then the value must be small, medium, or large of the field size, right? Everything is relatively easy, straightforward. And the same policy, again, except that the previous one applied to SQL claim being created or updated anywhere in a cluster, and this is, yes, but if the namespace is production, then the size must be anything but small, right? So 3 rules, relatively easy, relatively straightforward. Whose bottle is this? Whitney, probably. So let's see whether the policies are deployed. Policies, still not. I might have Argo CD UI running somewhere. If not, I'm in deep trouble. Argo kubectl get ing-a, where is it? Maybe I didn't. Yes. Kubectl port forward. Let's see Argo CD very quickly. Localhost 8080. Infra. There we go. This is the And I'm just going to refresh it, just in case. OK, let's see whether it's deployed now. Still not. Cluster policies. You know, I'm very happy when things fail later on, not at the very beginning of the demo. Oh my God, I'm going to get applications. I'm going to give up very, very soon. Nothing synced out, sync production infra policies, various policies, cut infra policies. Aha! I copied the wrong one. This is the right one. Ignore everything I said so far. Git add, git commit, git push, yes. Go back to Argo CD, refresh. There we go. Praise the Lord. Cluster policies, still not there. It will happen. I see it here. Look at it. It's all yellow. It will happen, I promise. You know what we said, Whitney, how we'll not make it, but through all the choices within a given period of time? That's happening right now. That's happening right now. Oh my God. Still not. I'm going to give up in a second. I promise. No demo for you. You don't deserve it. Cube Armour production apps for what did I copy? I don't know. What did I copy? Infra cover. Oh, yeah. No. Yeah, that's the correct one. Cut. You know what I just did? I overwrote Caverno with its own policies. So Caverno was deleted from the cluster. In my defense, I arrived to Cyric around 3 o'clock in the morning. That's what happened. OK. Now, I know that you're Swiss, meaning that you don't have great imagination. Imagine that it works for a second. And imagine that I tried to create a deployment with 1 replica, and it would say, no, Viktor, you're an idiot. You cannot do that. And then would change to 3 replica, and it would work. And use your imagination. I'm sorry. Whitney, the next one might work. Who knows?
Will you make this into presentation mode?
Now it's all about you, huh? There we go.
Perfect. That was a great job.
Amazing demo. Thank you so much.
So let's talk about runtime policies now that cluster level policies are crystal clear for us all. We are going to talk about 2 tools now. We're going to talk about Falco and Kube Armour. Why do we need runtime policy? Well, do you completely trust every single process that's running in your cluster? Do you trust your internal applications? Do you trust third-party applications? Do you trust your dependencies? Do you trust, like, there are hundreds, thousands, millions of processes running in your cluster? How do you know if just one is acting suspiciously? That's where runtime policy comes in. So with runtime policy, we're looking at what's happening at the kernel level. So we're looking at what's happening during application execution, unknown unknowns at runtime. And so in order to implement runtime policy, first you start by monitoring your Linux kernel, and then you use those events to define your expected behavior. Then you can write runtime policy that will do something when something unexpected occurs. And what that something is depends on the tool. So I'm going to jump right into the tools. First up, we have Falco, which is a cloud-native threat detector. So with Falco, you have inputs from the Linux kernel. You can do that with the kernel module or with eBPF probe. But you can also get inputs from plugins, like a Kubernetes plugin or cloud provider plugins, which is basically just looking at logs. There are 13 different plugins. And so with Falco, you define expected behavior with Falco rules, which are a set of conditions that when met, they trigger an alert. And so that alert is basically just a text message with some priority associated with it. Then Falco has a couple of sub-projects that help you handle those alerts. One is Falco's Sidekick, where you could forward the alerts to like 50 or 60 different compatible destinations. And then the other one is Falco Talon that actually takes action on alerts. So after a bad thing happens, then an action happens, like kill a container, for example, or maybe start collecting more information. Then we have Armour. Armour, it does monitoring. It does everything with eBPF. It does the monitoring. It does the alerting, but it does attack prevention. So Falco, an attack happens, and then an action happens. With Armour, when an attack is attempted, it is failed. It fails altogether. So that is done using LSMs, or Linux security modules, which are basically access control modules to the Linux kernel. All of it's done in a safe and performant way with eBPF. And then with both tools, have good communities that have community-provided rules for you to be able to get started. Although I will say Falco's a graduated project and Armour's a new kid on the block. All right, with that, what would you like to see Viktor demo, for better or worse?
Okay. Armour, huh?
All right, Armour it is.
It's moving fast, Falco now.
All right, that's definitive.
Okay.
Thanks, y'all.
Okay, so kubectl. Now, if I do namespace production and I try to execute into the container CNCF demo controller 0, which happens to be, doesn't matter what it is. What does matter is that if I enter into that container and let's say list all the files in the root directory, I should be able to do that, right? I don't know what's... I would like to say that normally it works better, but I might be lying then. Oh, fuck. Note to myself, don't prepare demo 5 o'clock in the morning after you arrived. Lucky for you, Whitney. We have more time to present the next choice.
Okay. So Viktor...
this is unacceptable.
Viktor literally hasn't gotten a single thing demoed yet.
No.
So it does usually go better, because there's usually one thing at least.
No.
It's all right. And,
it's not all right.
So here we go. We're going to talk about securing pod-to-pod communications now. And then with any leftover time, we'll see Viktor troubleshoot everything you can troubleshoot. So securing pod-to-pod communications, there are 3 dimensions to this. So first of all, we need each of our pods to have identity, and we need for pods to be able to verify each other's identity. Second, we want our communications between pods to be encrypted. And then the third thing is that, Viktor.
They can see this side of the screen.
Can you at least make it? I'm going to stand right here.
They see it. Don't worry.
The third thing is we need to write policy between pods. I can totally tell when your heads are pointed that way. Between pods, so that pods that shouldn't be able to talk to each other shouldn't even be able to talk to each other. You know what I mean? You do. My clicker's not working, Viktor.
Yeah, you want the next slide? Here's the next slide. Just tell me when you want me to change again.
Oh, this won't do. Can I stand up?
Okay.
I'm sorry.
Okay.
I was willing to try. Istio and Linkerd, they both do this. They both solve these 3 things in similar ways using a sidecar model. So I have a flattened cluster to illustrate this. So with sidecars or service mesh, what they're going to do is our technology is going to put an additional container into each pod. And that container is going to proxy request to and from the workload container. This can do a lot of different things in terms of connectivity and security and observability, but we're just talking about our 3 aspects. So this is called a control plane, our service mesh technology, and then these together can be called the data plane or the networking layer or the mesh or the service mesh. So it solves the first 2 aspects of securing pod-to-pod communication with MTLS. So that's done using X509 certificates that does identity and encryption. And then finally, we can do policy. Our control plane, our service mesh technologies will offer CRDs, that custom resources where we can handle policy for what pod should be able to allowed to connect to which other pods. So what differentiates Istio and Linkerd? Istio is a full-fledged, it has the most features of any of the service mesh technologies. If you can do it with any service mesh, you can do it with Istio. Istio also uses Envoy as the data plane technology. Envoy is very powerful, and it's also very complex. Linkerd still has advanced functionality. It can still do all kinds of things, but it can't do all of the things. It's slightly less things. But what it emphasizes is being easy to use, we'll say easier to use, and being more performant. So as its data plane, it has a custom written Rust proxy instead of using Envoy, and this custom written proxy is purpose built to be a service mesh. And the Linkerd people told me, I host another show, they came on my show, they told me that the Linkerd proxy takes up only 10% of the resources of what the Istio, the Envoy technology does. So I went to my Istio friend, I'm like, hey, only 10%, that's something, right? And they were like, oh no, that used to be true a few years ago maybe, but these days it's about the same. So I have a feeling the truth is somewhere in the middle. Then we have Cilium. Cilium is a CNI implementation. It's a whole different beast. So CNI stands for Container Networking Interface, and it's a specification for how a kubelet gives an IP address to a pod. So if a kubelet's making a new pod, kubelet and Cilium might have a conversation something like this. Hey, Cilium, can I have an IP address for a pod, please? Yeah, here's a networking stack that includes that IP address. Thank you, love you. And then Cilium's like, also, I'm going to give that pod you're making an identity using a technology, Spiffy. And Kubelet's like, this has nothing to do with me. And then Cilium's like, and I'm going to run an eBPF program at the kernel level in the pod network namespace. And Kubelet's like, please stop. And then Cilium's like, also with this program, I can capture all of the events that are happening from this pod and from every pod that I make for you across this entire cluster. And Kubelet's like, I think I hear Kube API calling me. I gotta go. And so with this program, it did do, again, all kinds of security, observability, and networking related things. But in terms of our 3 aspects of securing pod-to-pod communication, it can do identity, as we already talked about. It does that with Spiffy, and Spiffy will also help pods identify each other. And then we have encryption can happen with either IPsec or Wireshark. So in this case, as opposed to the other ones, identity is decoupled from the encryption step. And then finally, we can write policy and have it enforced with Cilium. So the thing about Cilium is Cilium has to already be running in our cluster to be able to use it, because a cluster cannot function without a CNI. And if we already have a different CNI and we want to use Cilium, it would be a very hard thing to switch out after the fact. So Viktor, is our cluster running Cilium?
I tried, you said that you cannot work without full screen.
In theory it is.
But the good news is that we have 5 minutes for questions.
Oh, you're not even going to try? You'll try. Everyone has to vote first.
No, it's not going to work without application deployed, and application is not deployed. And no.
Okay. So we're going to vote anyway, just because it's fun. And so even though Cilium's already running, that doesn't mean you can't choose Linkerd or Istio. They would run on top of Cilium, and there's reasons to have it all.
Or not.
To have it all, or to have none of it.
Or not.
So vote, please, and then we'll let Viktor choose what he wants to do with the rest of his time. Celia.
Yeah. I mean, it's Cilium is almost unavoidable. You're going to have Cilium no matter what, and then the question is whether you're going to put something on top of it or not, like linked Istio.
Excellent. So.
Great demo.
Yeah. Show us. Do you want to troubleshoot? Do you want to?
No, it's I cannot make it in 5 minutes.
Okay. I guess you have 5 minutes for questions.
Yeah, because the organizer said you have 25 minutes for talk and 5 minutes for question. We said there is no way we're going to finish in 25 minutes. No time for questions, but look at us. 5 minutes for questions. You know, I get better applause when it doesn't work.
It's so true.
Anybody, make it less embarrassing by asking something.
The QR codes, the ones you choose, and this one we do have a repo where you can, if you do want to see a demo and you want to do it yourself that badly, you can go to this repo and
So in repo you will have the instructions how to go through any path you choose from like probably 50, 60 projects so far.
Yeah. And you'll do it better than Viktor. There's no,
Undoubtedly.
Thank you. Sejubatyan, Alliance Direct and CNCF staff member. There's a microphone?
Yeah.
Oh, wow.
Oh,
Yeah.
Technology. Wow.
that's how Google spies on you.
Indeed. My question is about, I'm very much passionate and working currently on building reference architectures around cloud-native journeys. So I'm thinking about a reference architecture around domain, which is security, of course. What would be your preferred reference architecture? Like, what would be the perfect stack around security? What would you choose?
Within CNCF.
Mostly around CNCF projects, I would say, but you can use anything.
I mean, there are many parts of that answer, right? Depends for what. Like for runtime security, I would almost certainly go with Kubewarden, and I would use Falco as well, because Falco gives you the information you need, but doesn't. Falco is like, you know, if
You mean Cube Armour?
no, Cube Armour
Cube Armour.
prevents things. Cube Armour is kind of being educated about safe sex before the sex happens, right? Falco gives you information that you got the baby, right? Kind of, which is a very valuable information, right? Kind of like, you should know about it.
I'm very confused right now.
On a networking layer, that's Cilium. There is absolutely no doubt that Cilium is the winner. What else is there?
But on Cilium, how does it integrate, let's say, with the hyperscalers like GCP, AWS? Normally, CNI are like specific sometimes. They don't really fit in the landscape of a hyperscaler. Do you think this is going to be an issue or not?
In hyperscalers, yeah,
Like,
I mean, Google
let's say
offers.
AWS, for example, you want to have Cilium there, and
I'm running Cilium if this would work. In
trust
EKS,
you.
right? So no, Cilium definitely works in EKS, AKS, GKE for sure. It works with Civo, if I'm not mistaken. I mean, when I say works, meaning validated, tested, and all the stuff, it should work everywhere, really. There are some edge cases where you might have trouble, and I might be wrong, but I think that EKS offers it as a flag, AKS, sorry. And Google also offers it as a flag, and EKS probably doesn't, but it works for sure. So yes, the question is only whether the vendor baked it in or not, but more or less everybody chose. It's kind of, it's almost like getting close to the level of OpenTelemetry, kind of. We don't discuss it anymore. It's Cilium, right? We'll see now after the purchase of Cilium, but that's separate. What else? Secrets, that would be my preferences for ESO, External Secrets Operator. The rest is either useless. I mean, not useless, but SOPs is very hard to, there is no good, well-established operator for SOPs, so it's very hard to use it. The other one, which is the other one?
Secret store CSI driver.
The one that cannot be pronounced?
It mounts the secret as a pod to the, as a mount to the pod, yeah. And then nobody's expecting to receive secrets in their file system. They're expecting to receive, so it's cool that there's a technology that goes around Kubernetes secret because they're not so secret. But any third-party tool you put into your cluster is expecting a Kubernetes secret. So.
Yeah. So, so I don't know. I mean, there must be other. I mean, you know, ask more specific. Which part of security I did not mention, and I can answer it.
No, all of it. It's fine. I got an idea. The idea is to have an overview, the helicopter view, and from there, of course, you're gonna make the right choices. But
the most important tool that nobody associates with security is GitOps. You should use GitOps if you want to be secure, and the reason is very simple. If you use GitOps and Git and Flux or Algo CD pull stuff, that means that you can close the access to cluster and say nobody can access it. There is nothing more secure than an inaccessible system, right?
Yeah. It moves the threat boundary to the Git repo.
Exactly.
Yeah. Mm-hmm. That's a wrap. Our clock is blinking at us. I have You Choose stickers. If anyone wants any, come find me today, and I'll gladly hand them out. Thank you so much.
Thank you very much.
Hey, if they invite us next year, I will make it work.